Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the colligative properties of dilute solutions. Now if we study chemistry and if we think about the colligative properties, now first of all we should understand what are colligative properties. So we should understand this. So we can say that those properties of solutions which depend on the ratio of number of solute particles to the number of solvent particles in a solution are called colligative properties. Because in a solution, solute is there, solvent is there. So it deals with the number of particles of the solute and the solvent. We have to see their ratio. It does not depend on the nature of the chemical species which is present in the solution. Now we can also say that this ratio of the numbers can be related to various other units of concentration like molarity, molality, normality, and so on. Now these assumptions that the properties are not dependent on the nature of solute is exact if the solution is ideal, and these properties can be thought to be approximated if the assumption is taken that the solution is ideal, then only. Now, a solution, first of all, we need to define what is a dilute solution. Now, we can say that a solution is dilute if the amount of solute is very small when compared to the amount of solvent. Okay, solute is dissolved in a solvent. In case of a dilute solution, the amount of solute is very less. If in the dilute solutions there is a non-volatile solute, the solution is dilute as well as the solute is non-volatile. In this case, it will have some special properties. Okay, in this case there will be some special properties which will depend on the number of solute particles which are present in solution. Because here the solute is non-volatile, so the number of solute particles will determine some of the properties. These can be termed as the colligative properties, as I also told during the introduction. Now if we want to point out what are the colligative properties, what are some of the properties which can be termed under colligative properties. Now they are, first one is lowering of vapor pressure, second elevation of boiling point, then comes depression in freezing point, and fourth is osmotic pressure. We will definitely deal with all of these slowly, one by one. So these properties, if we want to relate, we can see that they are somehow related to each other, and also they help us to provide methods by which we can determine molecular mass of the dissolved solutes, because the solute is dissolved, so we can determine the molecular mass of such dissolved solutes in the solution. Now in order to get proper results, there are certain things or conditions which are to be fulfilled. First of all, the solution has to be very dilute. Solute should be non-volatile, and the solute should not associate or dissociate in the solution, because if it does so, the number of particles will not be the same. They will either increase or decrease. So these three conditions are essential. Now first we consider, as I told you, we will deal with one by one all the properties. First one is lowering of the vapor pressure. So first let us deal with lowering of the vapor pressure. Now students, if we have a non-volatile solute, when we add it to the solvent, the vapor pressure gets lowered. The vapor pressure will be lowered. Now why? we have to see and understand the reasons behind it. First thing being the surface area of occupancy by the solvent, that is the surface area which is occupied by the solvent decreases by certain percentage. Okay, so there is a percentage surface area which is occupied by the solvent, it decreases. When it happens, the rate of evaporation and vapor pressure also will decrease. Why there is a decrease in the surface area? Because solute molecules are there, they also occupy the surface. So the percent surface area which is occupied by the solvent decreases. So this is the first thing. Secondly, according to Graham's law of evaporation, we have a relationship between rate of evaporation and density. The rate of evaporation is inversely proportional to square root of density, which can be mathematically expressed by this proportionality equation. Now, if there is a mathematical expression by which we can term the relative lowering of vapor pressure, how we can do? If we denote vapor pressure of solvent by PS, PS vapor pressure of solution, and PO that of pure solvent. PO is that of pure solvent, PO. PO is the vapor pressure of the solvent, pure solvent. PS is the vapor pressure of the solution, PS, this is PS, vapor pressure of the solution. Using these two terms, we can determine or we can state the relative lowering of vapor pressure. Now, before relative lowering, first let us explain what is lowering of vapor pressure. Now say lowering of vapor pressure is PO minus PS. What is PO? PO is the vapor pressure of pure solvent. When it is present in the solution, then PS is the vapor pressure of the solution, because here solute is non-volatile. So the lowering of the vapor pressure can be given by the term PO minus PS. If we have to mention the relative lowering, then we take the ratio. So the relative lowering of vapor pressure is PO minus PS divided by PO, because PO is the vapor pressure of pure solvent. Now see, if we have n moles of solute, small n, we are representing the solute by small n number of moles. It is dissolved in the solvent. The number of moles of solvent is capital N. Then for finding the mole fraction, first of all we have to find out the total number of moles. So total number of moles is given by small n plus capital N. So mole fraction of the solute will be this one. Small n, that is number of moles of solute, divided by total number of moles, that is n plus n. So this is the mole fraction of solute. Now as per Raoult's law, PO minus PS by PO, that is the lowering in the vapor pressure, relative lowering of vapor pressure, will be equal to this mole fraction n by n plus n. Now this term n by n plus n, if we dissolve and write, it can be written as 1 plus n by n. Now if you reverse this PO minus PS by PO, if I just reverse it, we get PO by PO minus PS. So this side also gets reversed. It becomes n plus n by n, which is 1 plus capital N by small n. Now this 1 we shift to the other side, this one. If I shift it to the other side, it becomes PO by PO minus PS minus 1. If we expand it and solve, you see here, so we have to multiply PO minus PS with 1. So it becomes minus PO plus PS, because minus PS into minus 1 is plus PS. So after solving, what we get? PS by, because here PO gets cancelled here. Here you see PO gets PO and minus PO, they'll get cancelled. So PS by PO minus PS is equal to capital N by small n. Now again we take the reciprocal, so PS by PO minus PS, we take it, we just reverse it, it becomes PO minus PS by PS is equal to N by N, small n by capital N. So what is small n? WA by MA. And what is capital N? That is WB by MB. So when we division means multiplying by its reciprocal, so it becomes WA by MA into MB by WB. So I hope till here all of you understood. Next is derivation of Raoult's law for a dilute solution. Now when a non-volatile solute is dissolved in a volatile solvent, now some fraction of the surface of the solvent is blocked by solute molecules, because see, in the solvent solute is also present, so on the surface there will be some solvent molecules and there will be some solute molecules, but the solute molecules are non-volatile, so it will block the some percentage of the surface area of the solvent. In that area there will be no evaporation because the solute is non-volatile. So the vapor pressure gets lowered. So vapor pressure is lowered. So here the vapor pressure of the solution depends on number of solvent molecules, because I am again and again telling the solute is non-volatile. So the vapor pressure of the solution depends on number of solvent molecules which is present on the surface of the solution. So the vapor pressure of the solution will be directly proportional to N, capital N, that is number of moles of the solvent divided by total number of moles. So to remove this proportionality sign, we have to multiply with K. K is a proportionality factor. K is the proportionality factor. Now to find out the value for K, we take that the solvent is pure. When solvent is pure, N is equal to 0. Small n is 0 because there is no solute. So N is 0. So now PO is equal to K into, in place of small n we have to put 0. So from here we find that PO is equal to K. This value of K we put in equation number 1, this equation number 1. By doing so, what we get? PS is equal to PO into N by N plus N, that is number of moles of solvent by total number of moles, because capital N is the moles of the solvent. Now PO, this PO we shift to the other side. PS by PO is equal to N by N plus N. Now this side also we subtract from 1. So it is 1 minus PS by PO is equal to 1 minus N by total number of moles, that is number of moles of solvent, capital N. Number of moles of solvent by total number of moles. So by solving this, you can see I have solved it here. We get PO minus PS by PO equal to N by N plus N. N by N plus N. This is Raoult's equation. This equation, which is marked as 3, this is the Raoult's equation. So we say that if a solution is made by dissolving WA grams of solute in WB grams of solvent, then the mole fraction of the solute can be given as, mole fraction of solute is number of moles of solute by total number of moles. So number of moles of solute is WA by MA, because WA is the gram of solute, and divided by the molecular mass of the solute you get number of moles of solute. Take in numerator. Denominator is total number of moles, total moles. So moles of solute by total moles, that is WA by MA plus WB by MB. In case the solution is very dilute, in the denominator we can neglect WA by MA, that is small n. So by neglecting WA by MA in equation number 3, we go back to equation number 3. In this equation, in the denominator here small n can be neglected, so it will be small n by capital N, that is WA by MA divided by WB by MB. So divided by, when we take up, it is multiplied by its reciprocal. So finally what we get, PO minus PS by PO equal to WA by MA into MB by WB. So this is very useful to find the molecular mass of the solute, dissolved solute, by measuring the relative lowering of vapor pressure. We can see from this equation we can calculate the molecular mass of dissolved solute by measuring relative lowering of the vapor pressure. I hope you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to my channel. Thanks. Thank you very much.